Just right click on anything, click highlight new. Then if your computer isn't being annoying, then you can click new class. And we want to call this tile entity new furnace, which is what we were calling our variables and why it errored in here. So now we can finish that, and it should create our new class here. And just bear with me for 1 second. And this class wants to extend the tile entity class, so extends tile entity, and also wants to implement inventory. And then we will, so you are making a new class which extends tile entity and implements the inventory class. And then we are going to make some variables. So the first variable we want to make is a private variable which is an item stack, and what it wants to be called is we're going to call it contents, and it is going to be an array. So you put these two little square brackets, which means that this contents is equal to a load of item stacks. Then we are going to define a integer, so public integer called current item burn time, without a space, sorry, and that with a semicolon, and then public int furnace cook time. So basically this is the burning time of the current item that is burning, and the furnace cook time, I'm not quite sure what that is. It is the number of ticks that the item has been cooking for. So then we're going to create a constructor for our tile entity new furnace class, which is going to take no variables. And basically we're going to set our contents variable equal to a new item stack, which you need the square brackets on again, which has a length of 3. So basically this is setting our contents variable up here to to 3 item stacks. Then we are going to set this furnace cook time equal to 0. Oh, sorry, I missed one out. Public integer furnace burn time. And basically what this does is it is the number of ticks which the furnace will keep burning for. So then we want to set all 3 of these integers equal to 0. And that is all for the constructor. Then we're going to create a method called public integer get size inventory. And this is going to return our contents.length. So basically this method getSizeInventory, which is implemented by the inventory class, basically returns our item stacks.length. These item stacks correspond to each slot, so each slot has a different item stack, and this just returns the length of them all. So in this case it will return 3. Then next we want to do public item stack get stack in slot, which is going to have an integer of I within it, and I spelled item stack wrong, whoops. And this is going to return contents I without the P on it. So basically, when this method is called, this is the slot number, so either 0, 1 or 2, and it will return the stack, so the item stack within that slot, which is going to be the contents, and then either 0, 1 or 2, which is the slots, because we have 3 slots in it. Then the next thing, we want public item stack decrease stack size. So the actual, what it is DECR stack size, which is implemented by the iInventory class, so you have to get this right again, or it might be implemented by the talentity class, I'm not quite sure. And that is going to take 2 variables, which are both integers, so we are going to call them integer of I and integer of j. Then there's quite a lot of code to go in this one. So if contents I isn't equal to null, so if the contents of the passed in slot number isn't equal to null, so if there is something in this slot, then it's going to continue, and then we're going to add another if statement, which is going to be if contents I dot stack size is smaller than or equal to j, then it will continue to go through this statement. So basically the contents dot, you will pass in the stack, the amount you want to decrease the stack by. Yeah, basically. So then you put item stack, item stack, item stack. So we're going to make a new item stack variable called item stack equals contents I. So this new item stack is equal to the contents of the passed in slot number. Then we're going to set contents of our I stack equal to null. So basically what this is saying, is if our stack size is already smaller or equal to the amount we want to decrease, then there's no point going through all this code. It will just return it to null and completely just destroy the item stack. And then we want to return item stack. So basically what this is saying is it will set this item stack variable to the contents before it is destroyed, and then it will return it afterwards. So that's why we have that little bit in. And then we want another item stack variable called item stack 1, which is going to be equal to contents I dot split stack j. So it will split this stack in half, dependent on the j variable, I believe. And then we want to add an if statement, which is saying contents I dot stack size equals 0. Contents I equals null. So this is basically saying if there is nothing, if there is no stack size to it, then it's just going to set it to null anyway. and then we are finally going to return item stack 1. So basically what this is saying is this new item stack variable is equal to contents of our slot that's passed in, and it's going to split the stack among j, and then the stack left is going to be returned, and the other stack is just going to be depleted. And then finally here we just type else return null, like so. Then the next statement we're going to make is called public void set inventory contents. Sorry, set inventory slot contents. And this is going to take an integer which we're going to call I, and an item stack which we're going to call item stack. And within this we're going to type contents I equals item stack. And then we're going to have an if statement. If our item stack isn't equal to null, so if it has something in it, and the item stack dot stack size is bigger than get inventory stack limit, which is a method we will define in this class later, then continue to do what we want to do, which is set our item stack dot stack size to be equal to this. So basically what this is saying is if our item stack has something in it and the stack size is bigger than the amount of the stack size that we're allowed in this slot, then it will set this stack size to the maximum limit. Basically, if you put 100, say you've glitched it and you've got like a 60. Well, say you're putting a 64 stack in this slot, and this slot can only take 16, then your stack will now only be 16, if that makes sense. Then the next variable we are going to add is public string get inv name. So basically this is getting the name of your inventory, and this returns a string which we're going to say is container.new furnace. You don't really need to know what that does, but that is a method implemented by iInventory again. And then the next one is a void, so public void read from NBT, which takes an MBT tag compound variable. Oops, didn't mean to put a dot in there. Which is going to be called NBT for now. So basically, what NBT is, as I explained before, is it is the saving system for when you quit the game and join it, so your stuff is still there. So this is when we're reading from it. So the first thing I want to do is super.read from NBT. And then the next thing we want to do is make a new NBT tag list variable called, we'll just call it list for now, which is equal to our MBT variable dot get tag list, and in here we're going to type items, which we're going to write later. Then contents is going to be equal to a new item stack which has a size of get size inventory. Okay, sorry. So basically what that is saying is our contents variable is equal to a new item stack, which is the length that it previously was. So this is just resetting it when you open the game. So then we're going to make a for loop with an integer called I, which is equal to 0. And then if I is smaller than MBT dot tag count, list, I believe, dot tag count, then I plus plus. Then we're going to make a new variable which is an MBT tag compound variable called MBT1, which is equal to NBT tag compound. That is how you spell it, isn't it? MBT tag compound. Yeah, I think so. And then list dot tag at I. Then we're going to make a new byte variable called byte 0. And if that is which is equal to NBT 1 dot get byte slot. Yeah. Oops, that's meant to be on the other side. So we're making a new byte variable called byte 0, which is equal to our new MBT tag compound dot get byte slot, which we'll set in the next statement. Then we're going to do an if statement. If our byte 0 if our byte 0 is bigger than or equal to 0 and byte 0 is smaller than contents.length, then contents at byte 0 equals item stack dot load item stack from MBT NBT1. So basically what this is saying is if our byte 0 variable is bigger than or equal to 0 and our byte 0 is smaller than contents.length, so if our byte is bigger than 0 and is smaller than the amount of slots we have, then we're going to set contents of that byte to equal our item stack dot load item stack from MBT. Yeah, it's kind of hard thing to explain, to be honest. And then after that, we are going to set our furnace burn time equal to NBT. Sorry, equal, not minus. NBT dot get short burn time. Oops, burn time. And then we're going to copy and paste this 3 times, and then do it the same for our cook time, and change this to cook time. But we are going to, the last one, we're going to do current item burn time is equal to get item burn time, which takes contents 1, and we'll make this statement later. So that is it for the read. Now we need public void write to NBT, which is going to take an NBT tag compound variable called NBT. Then in the constructor, we're going to again do super dot write to dot write to NBT. Then we are going to do NBT dot get short. Sorry, dot set short. And then it's going to have a string of burn time, and then comma space. Short furnace burn time. So basically what this is doing is setting our furnace burn time to a string called burn time, so then when we read from the NBT, our furnace burn time is equal to that variable that we set before. So that is how it will save it. And then we can just copy and paste this, and then do the exact same for the cook time. So if we change this to cook, if we can spell it right, and change this burn to cook. Then once we've done that, we're going to make a new NBT tag list called list, which is equal to new NBT tag list, which takes no variables. Then we're going to make another for loop. Yeah, we're going to make another for loop with an integer called I, which is equal to 0, and if I is smaller than contents dot length, then I is to go up. Oops. Then within this for loop, we're going to add an if statement, which is if contents I isn't equal to null. So if there is something in our slot that we are using, then we're going to make a new NBT tag compound variable. Bless me, sorry about that. A new NBT tag compound variable called NBT1, which is equal to a new NBT tag compound, which takes no variables either. And then we're going to do mbt1 dot set byte slot, and then byte within brackets, and then just put an I on there. So we are going to set a list of bytes to a slot variable, basically. Oops. Then contents I dot write to nbt, and then put nbt1 within there. Then we want our list dot append tag nbt1. So what we're doing here is we're doing the for loop for the amount of slots there is. Then if that slot that is running has something in it, then this will pass. Then we're making a new mbt tag compound variable, and we're going to set a byte to the string slot, and that byte is the different thingy, the I variable, which is the amount of slots. And then we're going to write our item stack at I to the MBT, and then we're going to append the tag of list with our MBT. And then finally, down here we're going to do mbt.set tag, and our string is going to be items, which we set up here as well. And then here we're going to do mbt1. Or are we? Oh no, sorry, we're going to do our list. There we go. Then the next method we want to make is public integer get, a public integer called get inventory stack limit, which basically is just going to return 64. So we can put a full 64 stack in this slot. Then the next one we're going to do is a public integer called get cook progress scaled, which is going to take an integer called I, and within the squiggly brackets, or within the constructor, we're going to return our furnace cooking time times this I variable, which will be passed in, and then divide that by 200. Then we're going to make another statement called public int get burn time remaining scaled, which is also going to take an integer called I, and within this we're going to have an if statement, which is going to be current item burn time. So if our current item burn time is equal to 0, then we are going to set the current item burn time to be equal to 200. And then we were going to return our furnace burn time times our I variable, and then divide it by the current item burn time. Right, so that's that method done. Then we want a boolean method, which is going to be public boolean. A boolean is true or false, and it's going to be called isBurning. And basically we're going to return furnace burn time is bigger than 0. So basically, if our furnace burn time is bigger than 0, then it is obviously going to be burning, because, yeah. So then that method will return true. Then the next method we want is public void update entity. And it's a very big method. So the first thing we're going to do is make a new boolean called flag, which is equal to furnace burn time is bigger than 0. So again, this will return true if our furnace burn time is bigger than 0, the same as this. Then we're going to make another boolean called flag1, which for now we're going to set to false. And then if our furnace burn time is bigger than 0, then the furnace burn time is going to decrease. So basically, if it isn't equal to 0, then it is going to start going down as the entity updates. Then the next one we're going to do is if world object dot is remote. So basically what this is saying is the world object is an object of the tile entity class, which is basically just a world object. So if the isRemote method of the world class isn't equal, like is false, then this method will run. And the isRemote is basically is it a single player world. So then we're going to add an if statement, which is going to be furnace, if the furnace burn time is equal to 0 and can smelt, which is another method that we will add later on, then the current item burn time is equal to furnace burn time which is equal to get item burn time of our contents stack of 1, and we'll make that method later. Then below that we're going to do another if statement, which is going to be if the contents of the slot 1 is bigger than 0, then it's going to continue, and it's going to set our flag 1 equal to true. Contents. Sorry, that shouldn't be that. It should be furnace burn time. Sorry, and then we want another if statement, which is if contents 1 isn't equal to null. So if there is something in this first slot, then another if statement. Basically, there was a lot of code in this one thing, basically. And then this one is going to be contents one dot get item dot function, the function underscore 46056 underscore k. So just ignore whatever that is, I don't really know. So then we're going to do contents1 equals new item stack. Contents1 dot get item dot set for 3D. And then we're going to go else contents1 dot stack size minus minus. Then below that, believe it or not, we're going to add another if statement, which is going to be contents1 dot stack size equals 0. And within that you're going to type contents1 equals null. Then we want to go down 4 brackets, so 1, 2, 3, 4. Then below this one we want to do another if statement, and then if is burning and can smelt. Then furnace cook time plus plus. And then we're going to do another if statement. If the furnace cook time equals 200, then the furnace cook time is equal to 0. And we're going to run the smelt item method, which we will create later, and then our flag 1 is equal to true. And then below here we're going to do else the furnace cook time equals 0. Then below that we're going to do yet another if statement, and this one is going to be if our flag variable, which we made at the beginning, isn't equal to furnace burn time bigger than 0. So if our flag isn't equal to what? Yeah. So basically this bit here will return true if the furnace is on and false if it is not. So if our flag isn't whatever this is, then it is going to set flag 1 equal to true, and our block test furnace class dot update block furnace state furnace burn time is bigger than 0 for our thing, and then world object for our boolean, sorry, and then this wants to be x coordinates y coordinates and z coordinates of our tile entity. Then for this method we have our final if statement, which is if the flag 1 is true, then it is going to run that on inventory changed method. Right. Now, how long have I been recording for? Blimey. An hour and 10 minutes. Woot woot. This will probably be split into episodes, which you will know by now. And hopefully in this recording I'm going to get all of this class done. Fingers crossed. So the next method we want is going to be a private method, which is a boolean, and it is going to be called canSmelt. So obviously this is going to be true if you can smelt the item in the smelty slot, and false if you cannot. So the first thing we want to do is create an if statement, and it's going to be content 0 equals null, then return false. So basically if the content slot 0, which is going to be the slot in which you put what you want to smelt in, if there is nothing in that, then basically return false straight away because there is nothing to smelt. Then the next thing we want to do is make a new item stack called item stack, believe it or not, which is equal to furnace new recipes, which is a class we will make later, which will contain all of your recipes. Dot smelting dot get smelting result, which takes our contents zero dot get dot get item dot shifted index. So basically our new item stack is equal to any smelting recipes. The smelting is equal to the smelting result of the slot that we want, the item that we want to smelt. So then we want another if statement, which is if our item stack is equal to null. So again, if there is no, for this one is if there is no smelting recipe for the stack that we have put in, then again it is going to return false. Then another if statement, if contents 2 is equal to null. Oops. Then it is going to return true. And if our contents slot 2 dot is item equal to our item stack, then we are also, if it isn't, then we're going to return false. So basically what this one is saying is if the contents of the second slot, I'm trying to remember which slot that is. So this one, if the contents of the second slot is equal, so if there is nothing in the second slot, then it's going to return true. The second slot is the one in which, when you smelt something, it goes into that, so that is the smelting result slot. So if there's nothing in it, it will return true. However, if the thing that you want to smelt, so if the thing you want to smelt into, so if the smelting result isn't equal to what is already in that slot, then it's obviously going to return false, because you can't stack two items of different itemness. So then we want another if statement, which is going to be contents to, I don't know why I always type P there, dot stack size is smaller than get inventory stack limit, and if contents to dot stack size is smaller than contents to dot get max stack size, then return true. So basically what this is doing is, if our slot that we're smelting into, so if the result if the stack size of the result is smaller than the limit of that slot, and also if it's bigger than the max stack size, then it will keep going and it will keep smelting. Then finally, we want to return contents to contents to dot stack size is smaller than item stack dot get max stack size. So that is the can_smelt method, and we have just a couple of methods left. The next one is the public void smelt item class. Just check the time there. And if the can_smelt method is, add the brackets on there. If the can_smelt method is equal to false, then we are just going to write return, so it will return nothing. And then we're going to make a new item stack variable called item stack, which is equal to furnace new recipes dot smelting dot get smelting result contents 0 dot get item dot shifted index. So basically this item stack is equal to the smelting result of the item that you want to smelt. Then, believe it or not, we're going to add another if statement, which is going to be contents to equals null. Don't know why I've got such big spaces there. So if the contents of the one we want to put into is equal to null, then contents to equals item stack dot copy. And then we want an else if the contents slot 2, didn't mean to do that, dot item ID is equal to item stack dot item ID, then contents contents 2 dot stack size plus equals item stack dot stack size. So basically what this is saying is if the contents of the result slot is equal to null, so if there's nothing in it, then contents equals this dot basically equals the what we're going to put in it. Then else if the contents dot item ID is equal to this, so if it isn't equal to null but it is equal to this result, then it is going to add this to this, if that makes sense. Then we're going to add yet another if statement, which is going to be contents 0 dot get item dot function function 46056 underscore k again. Then within that if statement we're going to type contents 0 equals new item stack of our contents 0 dot get item dot set full 3D. Then we're going to add an else statement. Then else our contents at stack 0 dot stack size is going to decrease. Then if our contents at 0 dot stack size is smaller than or equal to 0, then our contents 0 is equal to null. So basically if, let's just take that out, put a space in there, if the contents of the first one dot get item dot whatever this is, whatever that function is, I don't really know what this one does, but the contents is going to equal a new item stack for some reason, and then otherwise the stack size is going to decrease. And then if the contents dot stack size is smaller or equal to 0, then there's no point in having a stack size, so it is going to be equal to null. Then we have 1, 2, 3, 4, 5 statements left. The next one is the last long one, so it is a static integer, public static int, called gets item burn time. And it's going to take an item stack variable called item stack. Oops. And first thing is what we're going to do is if the item stack is equal to null, So if there is nothing being wanting to be burnt, then we're just going to return this to 0 because there's no point doing anything else. Then our integer of I is equal to item stack dot get item dot shifted index. So this new I variable is equal to the shifted index of the item that we are getting the item burn time for. Then if I is smaller than 256 and block dot blocks list I dot block material equals material dot wood. Then we are going to return 300. So basically what we're doing here is we are setting what you can use as fuel. So this is setting a block. So if the shifted index is below 256, it means it's a block. And if the block material is equal to material wood, then it's going to return 300. So we could do this with anything like rock, but for now we're going to do wood. Then if you want to do it for an item, you're going to do if I is equal to your item that you want, so say an apple, dot shifted index, then it returns the burn time that you want it to have. So in this instance we're going to have something stupid. Oh no, we're going to have 10. We're going to have something small. And that is it for that statement. Then the next one, you want a public static boolean, which is called function underscore 52005 underscore b, which takes an item stack variable called item stack. Then we're going to return get. Why did I put brackets? I didn't mean to put brackets there. Or did I? No, I didn't. Get item burn time item stack is bigger than 0. So basically this method we could call is fuel, I guess. So if our item stack has a value which is bigger than 0, then it is going to return true. Then finally, or not finally, but this is the last main one. It's a public boolean which is called is usable by player, which is going to have an which is going to take an entity player variable called EP, and basically if our world object dot get block tile entity x coordinates y coordinates z coordinates isn't equal to this, return false. So basically, what's that saying is if the tal entity of the XYZ of the block that you're using isn't equal to this, then it's going to return false. However, it's going to return ep.getDistance square, then double times the x coordinates plus 0.5 d, then copy and paste this there and there, and change this to y and z. Is smaller or equal to 64d. So basically what this is saying is if the entity that's clicked on it is close enough to it, then it will return true. Then finally, the last two methods that are required is public void open chest and public void close chest, which need absolutely nothing in them, but they're just there because they are. I seem to have forgotten something. Okay, we forgot this method somehow. Don't know how I missed this method. Anyway, I'll just write it out again. Right, so last method, public item stack get stack in slot on closing, which is going to take an integer variable which we're going to call I, and within that it's going to be if the contents at the I slot isn't equal to null, we're going to make a new item stack variable called item stack, which is equal to contents I, and that should be a capital S, sorry. The contents at I equals null, return item stack. Then we're going to add an else statement. Oh sorry, that should be equals. An else statement which just has return null. So that is it for all of that, and then these errors should clear up once we make our new... oh, sorry, that should be there. When we make that class and that class, oh, sorry. This should be, we need our else statement in here, which should be else return 0. Or if you want, you could use mod loaders. In fact, ignore that. So that is it for this set of, how many tutorials is that? 13-ish tutorials. So I've just recorded them all in one. I hope you enjoyed that. I hope that helped, and I hope I was thorough enough with the explanation. In the next one we'll be covering the other files. Hopefully we should get them all done in the next one, because there isn't too many left. These are the two big ones that we have done so far. So thanks for watching, guys. I hope that helped. And also, just to let you guys know, I am thinking of doing a live stream. I might have already done it by the time I've uploaded this video, I'm not sure. But I'm thinking of doing a live stream in the near future, where basically over say 12 hours or some sort of time period, I'm going to be making a mod and live streaming it, and also I'll release it afterwards with all the source code, so you guys can watch me make a mod. And yeah, I hope you guys will enjoy that experience, and I'm going to try and be more active now, because I've kind of semi-finished school. I've still got other things to do. Yeah. So I'll try and be more active, guys. So thanks for watching, and I will see you in my next video.